Let x comma y be positive integers such that x to the power 4 equal to x minus 1 whole thing into y square minus 23 minus 1. Then can we find the maximum value of x plus y? The answer is yes. Let's do it. So let's write the given equation once again. X to the power 4 equal to x minus 1 whole thing into y square minus 23 minus 1. Let's call this to be equation 1. You see that we have x to the power 4 on the left hand side and x minus 1 as a factor of this quantity on the right hand side and then minus 1. What if I subtract minus 1 on both sides? I know that x to the power 4 minus 1 is having x minus 1 to be a factor. So we just subtract 1 from both sides of this equation to obtain x to the power 4 minus 1 equal to x minus 1 whole thing into y square minus 23 minus 1 minus 1. Now we see that now we know that a square minus b square equal to a minus b into a plus b. So x to the power 4 minus 1 equal to x square whole thing square minus 1 square. That's equal to x square minus 1 a minus b into a plus b, x square plus 1. Once again x square minus 1 can be written as x square minus 1 square, and that's equal to x minus 1 whole thing into x plus 1 into x square plus 1 as it is. So x to the power 4 minus 1 can be replaced by x minus 1 into x plus 1 into x square plus 1. Let's do it. That implies x minus 1 into x plus 1 into x square plus 1 equal to x minus 1 into y square minus 23 minus 2. See, this is a multiple of this quantity is a multiple of x minus 1. So does this. Let's write this to the left hand side. We bring it to the left hand side and take x minus 1 common. Once I take x minus 1 common, we will be left out with x plus 1 into x square plus 1 minus y square plus 23 equal to minus 2. You see that this is an integer. Since x is an integer, x minus 1 is also an integer, and again x and y both are integer, this expression is also an integer. So product of two integer equal to minus 2. In other words, x minus 1 is a factor of 2. But only factor of 2 are plus minus 1 and plus minus 2. Therefore, I can say x minus 1 equal to plus minus 1 comma plus minus 2. So when x minus 1 equal to plus minus 1, let's write it this as x minus 1 equal to 1 comma minus 1 comma 2 comma minus 2. So what about x then? We just need to increase 1. So 1 plus 1 is 2, minus 1 plus 1 is 0, 2 plus 1 is 3, minus 2 plus 1 is minus 1. So the only possible integer x that satisfy the given equation are x equal to 2, 0, 3, minus 1. Let's write equation 1 once again. X to the power 4 equal to x minus 1 into y square minus 23 minus 1. When x equal to 2, you see 2 to the power 4 is 16, 2 minus 1 is 1. And that's equal to y square minus 23 minus 1. That gives us y square equal to 24 plus 16, that's 40, which is not possible. So we cannot take x equal to 2 because when we take x equal to 2, we were not able to determine the integer y. As we know, y is an integer, y square cannot be equal to 40. Y square is a perfect square and 40 is not a perfect square. Now when x equal to 2, we have ruled it out, that's not possible. 0, when x equal to 0, 0 equal to minus 1 into y square minus 23 minus 1. That gives us y square minus 23 equal to minus 1. So y square equal to 22. Again, not possible. It's not possible. So we rule out the case x equal to 0 as well. Next, when x equal to 3. 3 to the power 4 is 81. Equal to 3 minus 1 is 2, so 2 only. Y square minus 23 minus 1. 81 plus 1 is 82. 82 divided by 2 is 41. 41 equal to y square minus 23. That gives us y square equal to 41 plus 23. That's equal to 64. So you see that y equal to plus minus 8. Therefore, so we see that x comma y equal to 3 comma 8 and 3 comma minus 8 are integral solution of equation 1. Lastly, so okay, we got 3 comma 8 and 3 comma minus 8 to be integral solution. What about with x equal to minus 1? When x equal to minus 1, let's write the equation once again. X to the power 4 equal to x minus 1 into y square minus 23 minus 1. We write x equal to minus 1. So minus 1 to the power 4 is 1. Minus 1 is minus 2 into y square minus 23 minus 1. Take minus 1 to the right hand side, you will get plus 2. And 2 by minus 2 is minus 1 equal to y square minus 23. And if we solve for y, we'll get, we won't be able to get integer solution. So y square equal to plus 23 minus 1 is 22. Again, not possible. So we see that minus 1 comma y do not satisfy the given equation. In fact, what we see is that 3 comma 8 and 3 comma minus 8 are the only solution. Lastly, we see that 3 comma 8 and 3 comma minus 8 being solution. X plus y is 3 plus 8 is 11. 3 minus 8 is minus 5. So maximum value of x plus y satisfying the equation 1 is, if x comma y satisfy the given equation, is 3 plus 8, and that's equal to 11.